50 positive because it's in tensile. Divide by 0.799. Okay. Then I'm just going to do my. I know my element H will be equal to 0, right? So why is it 0? The moment for my is 900. I put plus minus because it does not matter, it will be 0. And then multiply by IYY or IZZ. So this is also equal to IYY. This is also equal to IZZ. This is equal to 309.894 times 10 to the power minus 3. Now, why is it equal to 0 for element H? Okay, so this is our 900. Okay, so the 900 for my, right? Element H is at the centroid. So the Z distance is equal to 0. Okay. And the last one on element H due to mz is going to be positive. So mz, okay, mz, moment about z, right? So moment about z, this is top and that is the bottom is at the top. So plus, right, 1500 multiplied by the radius and then divide by 309.894 times 10 to the power minus 3. So this will be equal to 150 divided by 0.799. By 150 divided by 0.799, 187, positive 187.735 plus 1500 times by 0.95 divided by 309.894 power minus 3, 4.598 times 10 to the power 3. Okay, I'll do it again. 1500 times by 0.95 divided by 309.894 power minus 3. 4.598. So the answer is 4.598 power 3 plus 187.735 is equal to 4.786 times 10 to the power 3 psi. Okay, so that is for element H. So now if we were to do for element K, we know that the axial load is the same, right? So now we are looking at element K due to my, element K. Okay, so element K due to my, element K is on this side, so it's on compression. So minus 900 multiplied by 0.95 divide by 309.894 times 10 to the power minus 3. The next one does not matter because mz, right, for element K is equal to 0, right? So mz is this moment over here, right? And over here is at the centroid, K is equal to 0. So it's equal to 1500 multiplied by 0 divided by 309.894 times 10 to the power minus 3. So you have plus by 187.735, and then you have minus 900.95 divided by 309.894 power minus 3. You get 2.759. Let me do it again. 900 times by 0.95, 309.894 power 3, 2.759, which is correct. So this is 187.735 minus 2.759 power 3. Oh wait, 187.735 minus 2.759 power 3 is equal to minus 2.571 times 10 to the power 3 psi. Okay, so this is how you find your stress, normal stress, H and K. There is shear also, but I'm not doing shear yet because I'm not taught shear yet. We're going to focus on normal stress. So now
Yeah.
you can see now, right? How important are all these analyses? Can you all see that? Right? How important these analyses are. Once this analysis is done, over here is so easy now. Okay. And I hope you all will follow that trend. Okay. The thing about this course, there is a lot of steps. Okay. And there's a lot of analysis. It's not just, okay, I'm just going to plug in the formula. You can see from term test one, it's not just about formula, it's the analysis. Okay. So when you do your homework, just look at the final answer. You have to be able to do the what? The analysis. I think that is more important than anything else. Is the analysis. Okay. Now we are going to next do our next question. Someone has question. This is considered a difficult question or not? No, this is considered an easy question. The thing about this example is you have to know, okay, like what I've been teaching before, like how to find what is the axial load and what is the moment, and whether the moment is going to induce a tension, a compression, or zero stresses. That is more important than anything else. Okay, so do not memorize. Okay, if you memorize what's going on the homework, okay, game over. Okay, it's the analysis. Okay, that's where this cost the fail not the failure rate. The class average is not superb. In the winter term, the class average was a C minus. Okay, and most of the courses they've taken, how many of you have taken courses that are C minus? Most of them are either B plus, or A minus, right? So why? Because it requires analysis. You cannot memorize, okay? Because if I change if I change like the direction of the arrow, if I change a cross-sectional area, you have to analyze. Okay, that's more critical than anything else. Right. The next problem, once you see it, you say, oh, this is worse. Okay. We are going to go for the next problem now. Now, this problem, okay, it might look like really, really bad, but it's not that bad. Okay. First time you look at it like, whoa, okay. When you start looking at it further, it's not that bad. You just follow the procedure that I advise you to solve. Okay. Right. Yeah, I could not remember what example is this now. 4. Okay. Example number 4. The 4 forces are applied to a YW200 X 41.7 Robin as shown. Determine the principal stresses and maximum stresses at point. I don't want to determine the, so I'm just going to change the question. We are going to determine the normal stresses acting on elements A and element B. Okay. As I say, I'm not taught shear yet, so I don't think we have the ability to find the principal stresses yet. Okay. Right. So what we have is a 3D load. Okay. And then the information regarding the beam is here. Okay, so this is the information that were given on the beam. And then on the beam, this is the diagram with the corresponding dimension, what it actually means. First of all right, whenever you have a problem like that, make sure that the transformation on the question and the transformation on the diagram are the same, because sometimes it could flip, and when it flip, you did not flip the axis, you're in trouble. Okay, all your axes will go wrong, right? Right. So so from the table we know. Okay, so this is the first time all of you are looking at a table like this. No, not the first time. We did that in, I could not remember, did we do that in Berkeley? But anyway, okay. So the beam that we're going to use is this beam over there. I'm highlighting. So all information are provided. As I said, you must make sure that the X over here and the X over here, they have the same orientation. Then you're okay. If not, you have to adjust. Okay. What are the things that are required? Okay. So the general formula is stress X, or for this case, it's no more stress X. And I'll tell you why no more stress X. If you look at the transformation now, this is our X. This is our Y. This now is our Z. Right? So the phase that's going to fail is this phase will break. Okay. And if that phase will break, what we're interested is a stress in the Z direction. Okay. So there's a stress in Z direction, and that's a phase that we're interested. Okay. So stress in the Z direction, this will be equal to Px over A, or Pz over A now. Or I'm going to do plus minus, we don't know yet. Plus minus, now My or Mx over Ixx multiplied by Y, plus minus My over Iyy multiplied by X. Okay. So things that we have to know is A, Ixx, and Iyy. So we know that A, right? So A is, we look at this column over here, is 5310 times 10 to the power minus 6. Convert them immediately to meter squared. Okay. And then the next thing that we know is we can find our Ixx. Right? Ix is equal to 40.9 times 10 to the power minus 6 meter to the power 4. And then we can also determine our Iy